What's going on, everyone? We're going to get started here in about 2 minutes. What's going on, everyone? Can everyone hear me okay? Let me know in the chat if I'm loud enough. Everyone's good to go. Okay, that should be good. Alright, we're going to get started. Welcome to the stream. Hopefully everybody having a good Saturday. Today we're talking about security. And before I get started, I want to make sure that if you have any questions related to security, we're talking about like app security, service security, cloud security, database, code, and then some, well, I guess that's it. So if you have any actual questions about security related matters, please ask them in the chat here, and I might answer it live. We're kind of looking at security at a high level, and we're not trying to address every little security thing and answer every little security thing. Basically, this isn't designed to be kind of an in-depth tutorial on all different security matters and how to basically solve each one, but we're going to kind of look at it at a high level. So if you have any questions, please let me know. As far as just a quick channel, hold on a second, I got to update my segments. That's not the right stuff. Sorry about that. Okay, that's better. So a quick channel update, and I wanted to talk about the streams specifically as well. I've been doing kind of the same sort of streams for the last, I think I did my first one August of last year. So I try to cover almost like philosophical topics or engineering topics, but in a philosophical manner. I do more talking than I do coding, and I've had some feedback on that. People want more coding, but I try to avoid that because I don't want this to replace a Sunday video, which is kind of a lot of knowledge in 5 minutes. The stream, I kind of want it to be interactive. I want it to chat with people in the stream, get feedback in the chat, and then address those as part of the stream, more interactive. I didn't want this to be sort of a one-way, I talk to you about things and that's sort of it. So the reason I bring that up is I'm always looking for feedback on if I can make the streams better and how I could make those better. So if you have a good idea or you have something that you'd like me to do that I'm not currently doing, please let me know or let one of my staff know. Come on to Discord, let me know there. I'd really appreciate it because these streams are all for you guys, and I want them to be as best as they can for you. And to do that, I'm always open for feedback. I of course don't have all the answers. So that's kind of the big thing I wanted to put out is we don't have to keep doing the same thing every other Saturday. I try to just pick new content that I can talk sort of in the abstract, and it seems to be good right now, but it might be better. Just let me know if that's the case. Also, we're approaching 200,000 subscribers pretty soon. That should happen here in the next couple weeks, so we're going to do a special video. I know I've been saying that since the 100,000, but it sort of snuck up on me kind of quick. So I'm gonna actually do a special this time. And then other than that, I think that covers that. So I'm gonna answer some questions, and then we're gonna jump into some security matters. Basically, what I've done is I'll actually show you real quick. So I have several topics, related to cloud, web development, database, and then code. And then we're just going to talk about each of those kind of individually, and some of the gotchas, some of the tips and tricks there. So we'll come back to that in a second. So we'll start with some questions. Michael Ricks Ahern asks, what are your thoughts on Docker container security, best practices, hidden gotchas, etc.? So thanks for that question. I actually didn't include Docker in here, but I probably should have. So I'm glad you asked that, because we could certainly talk about that. So, Docker in itself can be helpful with security or harmful with security, because Docker, it does create a container around your application. However, there are a couple things that you can do with Docker to sort of shoot yourself in the foot. The first thing is you can run it in privilege mode, which gives the application inside Docker a lot more privileges. The other thing that can happen is you can accidentally mount an important folder in the container from the host, and then the container can just delete those files on the host. And of course, that's harmful. So there are, Docker can be a great tool, or you can shoot yourself in the foot with it. The other thing that can happen with Docker is you can accidentally create a network link, possibly an unsecured network link between the container and the host. You can possibly create a way to log in with SSH from the container to the host, and that of course could be harmful. But I believe Docker is a force for good. I don't think it's a force for evil. And I think it helps a lot more people than it harms. Are there vulnerable functions in programming languages? There aren't. That's tough to answer. I mean, anything that's used the wrong way can, of course, be harmful to your application or your users. So I don't think there's many intentionally vulnerable things, because of course the language designers would have removed those, but they, like for instance, PHP has the exec command, Python has the os.system command, and of course that can be very harmful. If user input, for instance, is allowed to get into those functions, it can cause some harm to your computer. So are they vulnerable? Yes, but they sort of have to be, if that makes any sense. Functions that are powerful are also the ones that are most susceptible to, harm. Yanni asks, how can I secure my C code? We're actually going to talk about that. That's actually one of the topics on my list of things, so we'll get into that later. How to manage the attack surface for a large web app. So I think I'm going to actually end up covering that as well in the topic, so I'm going to skip that one as well. Then Richard Soper asks, what do you think about Trafic reverse proxy system? I actually have no knowledge of that tool. You should post a link for me, though, either here or on my Discord, so I can check it out. I've never heard of that, but it sounds interesting. Okay, so let's jump in. That's it for all the questions that I saw here. Let's go ahead and jump into the actual main topics. Let me get rid of this. Actually, let me first make myself a little smaller. Kind of big. There we are. Okay. So I didn't put these in any particular order. I did want them to be sort of broader categories that we would talk about. I started with cloud, and then I did web development, and then database, just to sort of separate them up. But they all have their individual sort of security concerns. So talking about cloud servers, the first thing is firewalls, and a lot of this stuff that we're talking about here before we get into firewalls, a lot of this stuff is what I like to call low-hanging fruit. Like this is the really easy stuff. It's the really simple things to solve, but it's also the most common. A lot of these things are, uh, lend to people, exploiting applications and getting access to things that they shouldn't. But a lot of these things are really easy. It's just sometimes people just either aren't aware of them, or they're not sure how to accomplish it, or they're just maybe new in the trade and they're not even sure it exists. So, if you have a cloud server, you need to have a firewall. That goes without saying. But it's sort of convoluted because firewalls can be delivered to a user in a number of different ways. Like some particular things, for instance, like Linode, DigitalOcean, Google Cloud, they all have managed firewalls, meaning that you can manage your firewall from within the control panel of the cloud host. You don't even have to do it through the VM. And that's just an additional service. It's not that they don't allow you to do it through the server. It's just they give you the option to do that. So that would be managed firewalls. You can use that, but the purpose of a firewall, I should have led with this. Purpose of the firewall, of course, is to block off ports from all or some or all IP address ranges, and then allow certain ports. A typical firewall starts with nothing allowed, and then you go from there. So one of the first things you'll probably allow is port 22 for SSH, and then if your application needs port 80 and 443 for HTTP, HTTPS, then of course you would allow that. And usually that's all that you expose for a basic web server. However, it's not uncommon to come across a server that has everything open, like Redis or MySQL or some mail server, and then a litany of other things. And of course, usually if that's exposed, but it's not actually used for some purpose, it's almost always an error, and it's almost always a vulnerability. So that's what a firewall is. And you can manage it through either your cloud host, if they offer that. There's also IP tables for some older Linux distributions, but newer distributions will use Firewall D or UFW. Firewall D is specific to your Red Hat distributions, and then UFW is going to be for your Debian, your Arch, your Ubuntu, and so on. But each one does the same thing. They open ports to allow things to work with the thing. Okay. One thing came in. Can you elaborate what a DMZ is in comparison to a firewall? So a DMZ is sort of... Okay, we're going to come back to that because I don't want to convolute like home network DMZ, because a lot of people when they hear DMZ they think of the setting in like a consumer router. So I want to come back to that. I'll come back to that later. So the second thing in the cloud is passwordless logins. And I see this a lot. I come across servers that still accept passwords, and there's really no need for that. If passwords are insecure, I mean, of course, if you have a 64 character password, okay, well that's not insecure. But a lot of people just have 1 2 3 4 5 6 7 8. I've seen that, and I've seen that on servers that are exposed to the internet, and it's insane. So you can accomplish a passwordless login by using public key, private key authentication with SSH. And if you're not sure what that is, you should definitely look it up. But essentially what it is on your machine that you use to log in, you create a public key, private key pair. And then what you do is you take your public key and you insert it onto the cloud server as an authorized key. And then when you go to connect to that server, the server will match your private key with that public key. And if it matches, it'll just let you into the server. And these keys are far more cryptographically secure than something like a short password for sure. And this also has the added benefit of you don't actually have to remember the password. So there's no, because the reason people create such short passwords is because they have a hard time remembering it. If you can remember a 60 character password, fantastic. That's going to be just as fine as public key, private key authentication. But one of the first things that you're going to want to do is create that public key, private key pair, and then just disable password authentication altogether. So no logging into your cloud server with a password. If you're doing that, you should probably not do that. So the next matter with a server is running with the least privileges. And oftentimes what I'll see is people will create servers and then they'll be automatically given root access either because that's what their host does or for some other reason, and then they'll just run everything as root. And of course that can be harmful, because if you have an application, say you have a Python application and that Python application is running as root, if somebody's able to exploit your application and somehow get access to a function that maybe runs a system command, it's going to be able to run that command as root. And of course that's very harmful. If the application was just running as a user called, say, web user or Python user or app, whatever, if it's running as a non-privileged user, then the worst it can do is harm its own files and its own things that it can access. But if it's a non-root user, it can't like nuke the entire system or anything harmful like that. So you want to aim to run your stuff as the least privileges required, and sometimes, unfortunately, sometimes the least privileges required is going to be root, and that's in the case where it's a program that actually needs to perform tasks to which it requires root access. And like Docker is a good example of that. You know, Docker does not run. Docker runs as root. It can't run anything else. One guy in the chat said, "I'm running everything as root. I'm too lazy." And I'm not. It's funny you write that, because you're not alone. A lot of people do that. It's easier to just run it as root, because a lot of the times running as a non-privileged user requires some overhead. You got to create the user, and if that user requires some special access to something, then you got to configure that appropriately. And sometimes it's easier to just say, forget this, I'm not going to do it. I'm just going to run everything as root, and it'll all be fine. Yeah, developers are lazy. Absolutely, Zach. And I mean, I'm even somewhat guilty of that. In the past, I've done that exact same thing. I've said, you know what, I don't have time for this. It's too much effort to configure everything properly, so we'll just run it as root and just call it a day. But I don't do that anymore. I try to run things with the least amount of privileges. The last cloud topic is, actually, hold on, let me check. Are public key, private keys the same as using Active Directory? I don't actually know. I'm not sure. I'm not a Microsoft guy. I don't know if that's the case. Maybe somebody who knows more about Active Directory in the chat can answer that. But I'm not sure. Thank you for that question, though. I'm not sure exactly how those compare. So our last matter in cloud is, yeah, it's like the people who say forget SC Linux. That's another good example. Kev runs on Duncan. We've talked about SC Linux on this channel before. I did a stream a while back called Getting That Sweet Website of Yours Online, and I used the CentOS 7 server, and rather than disabling SC Linux, I showed people the 2 commands that you would need to just make your app work with SC Linux. It's not that hard. They're only trying to help, by doing SC Linux. And of course, not all Linux distributions have SC Linux. Some have, I think Ubuntu has what's it called, like App Armor or something like that. But they only have these additional layers of security to just make your system more secure. And if you just disable it, you're cutting off, that layer of security. So engineer man is a back-end engineer. I do everything. I do front-end, back-end. I do all kinds of stuff. Okay, so the last cloud topic is something I could call an inlet server. And this is something I like to use just to sort of further reduce the amount of things that an attacker can see on normal servers. So imagine you have like 10 servers you manage. You have 5 HTTP servers, 3 database, and 2 object cache servers, something like that. And how do you go about managing all of those? Typically, what a lot of people do is they'll just run SSH on every one of those servers. SSH with port 22 exposed, and then they'll just log into each server individually. I don't particularly like that. I think that's you're making it easy for an attacker, because they can They can find those servers and they can try to access them. What I like to do is use an inlet server, and essentially what this is it's a server that is ultra hardened. It probably has an IP whitelist, and it's designed to allow everybody to log into that server, and then from there you can laterally move over to all the other servers. Now, what this allows you to do is, if you're using any cloud host that's worth its weight, then they likely have private networking. And what that allows you to do is log into one server, and then you can log into the other servers using private IPs. So that way you could still access them. It's just you have to be on that one server. People in the public, they can't actually log into the server or even see the ports open. So it's like if, like emkc.org, I could cut off port 22 on that, but then allow it through some other server. So that's one way of just making it so none of your servers have SSH access except for like one or two, and then you can use those to laterally move over. How to find vulnerabilities in a shared server? Well, you probably don't have to look that far, because shared servers usually just hundreds of people's applications just piled into one server. So I think shared servers are just intrinsically vulnerable, just because you're not the one managing the security, the host is. Is filtering IP can help in securing server? Yeah, of course. I recommend that specifically for SSH access, if it's not a complete inconvenience, to just whitelist people's IPs and just allow certain IPs to connect. But again, you have to kind of look at what the end result of the application is. If it's just some testing server that has nothing important on it, well, whatever. I mean, do whatever security you feel like doing. But if you're responsible for customer data, if you're responsible for private information, sensitive information, financial data, or stuff like that, you have to be doing these things. You have to be making it secure. You have to be using all the best practices. You have to limit people's access to the computers. And in the end, you have to be a good steward of their information. And if you're not, you're doing yourself a disservice, your organization a disservice, and of course you're taking actions that are potentially harmful to your customers. And of course that's not good. Yes, I completely forgot about fail to ban. Yes, thanks for that. Yeah, fail to ban is another good thing. I think that's too low level, but I'll just state that essentially what fail to ban is, it's a simple thing you can install on Linux that just automatically blocks people's IPs after they take some action too many times. And I say that kind of broad because you can configure it. You could say, like, if somebody has 10 failed SSH attempts, or they have more than 1,000 requests in a minute, then just cut off their IP for X amount of minutes. This sounds familiar. Is inlet server the same as Bastion server or Edge node? Bastion server, yes. Edge node makes me think of something like, like edge caching, trying to get servers closer to the right people. But it's possible that's just another word for inlet server. Inlet's just something I made up. It's probably not an industry term, but as long as people understand the purpose of it, it's one server as your starting point to escalate into various machines on your network. Yeah, fail to ban is total crap, slows down web servers. There's some, I neither agree nor disagree. I think it's kind of, you have to look at it as, is it helpful or harmful, and then make your decision based on that. So, okay, that's it for cloud stuff. So I want to move on to web development. And the reason I move on to web development as a specific category is because browsers are almost the de facto application for creating, new applications. And people might not agree with that, but you got Chromium engine, which of course very powerful, and then you have now Electron, which is a new way to make desktop apps, and then of course all phones have browsers. It's the most popular platform for building applications. So I say web development. Even if you're not a web developer, you are eventually going to work on web development type stuff, and then you're going to see these kind of exploits and vulnerabilities on the web. So it's important to understand them. So the first one is SQL injection. SQL injection is where somebody takes a string of characters and inserts them into an input field, and then that input field gets inserted directly into a query. And then in effect what that causes is there's a query that's being ran on a database that the user did not intend to be ran. So for instance, like I could insert a new query in there to just drop your database or delete a bunch of tables or add a new user, something like that. And the way you protect from SQL injection is it's very easy to do. All you have to do is escape certain characters. Because you can imagine that the reason people can SQL inject is because they can use quotes to end your current query. They can then terminate with a semicolon. They can write their own query, and then they can use comments. So as long as you are escaping these characters, basically instead of putting a quote in there, you're putting a backslash quote, then MySQL will see that as an actual quote instead of the end of its query. So yeah, rule number one, sanitize your inputs. It's as simple as that. If you sanitize your inputs, then you're not going to have any problem with SQL injection. As a follow-up, I have down here in code, I have framework and libraries, and I want to just jump down there for the purpose of this because I put this in here because a lot of frameworks and libraries have data layers built in that are already protected from things like SQL injection. So typically, if you're using modern tools and you're not writing your own raw queries, you don't generally have to worry about things like SQL injection because they've already handled that. If it's a popular library, it's not going to be vulnerable to SQL injection, at least not knowingly, and at least not so overtly like writing your own manual query and just inserting a value into that which somebody can, add a new query and do harmful things to your database. So I bring up frameworks and libraries just to say that you should try to use established tools already. Don't try to reinvent the wheel on this. There's so much harm that can come from SQL injection that it makes sense to just use tools that are already protected. The other thing you could do is things like stored procedures, which are actual queries that are already in the database, and then you just provide it parameters. And when you provide it parameters, you don't have to worry about escaping anything because it's not actually like inserting the value of that parameter into the query. It's using it as, kind of hard to explain. Basically, it's not actually a query. MySQL is taking a parameter, and in effect, MySQL itself is doing the SQL injection prevention. Yeah, scammer video is gone. That's gone, unfortunately. But that was a good example of a SQL injection vulnerable application. So next thing is cross-site scripting, and this one is kind of harmful. That one can be very harmful in certain cases. So essentially what cross-site scripting is it's when I take arbitrary JavaScript and I insert it into an application, and that application later serves it to some user. So a good example is, let me open up EMKC or somewhere. One of my staff actually did a cross-site scripting example on here, and actually there's a somebody had a name at some point, and that name had angle brackets, not angle brackets, sorry. I'm gonna brain fart. It had a script tag, not a script tag, but it had like a bold tag or something like that, and I was looking at it like, what, why is that bold or why is that italic? And it turned out that I had one area in this application that was just taking HTML and just putting it into the system. I've since fixed it, but imagine if, let's go to snippets. So imagine if I wrote some JavaScript here. I did a script tag, and then in here I did location equals Google. So if this script were to execute, it would redirect the person to Google. But because I'm escaping this information, it doesn't actually go anywhere. But imagine if instead of escaping these tags, it actually ran this script. And imagine if I did something like, let me find another application, like Google. So imagine if I had Google here, and imagine if I put that in there, and then it actually executed that script. It would redirect me to Google. So if somebody can take arbitrary JavaScript and insert it into your application, and then somebody else can have that JavaScript executed on their machine, then that's of course a problem, because I can do things like steal your cookies. I can, if we're going to talk about that later. There's a couple other cookie concerns that we'll address, but if I can access your cookies with my arbitrary JavaScript and then post them to another site, then I now have access to your cookies, and I can therefore hijack your session. But the other thing I can do is I could just redirect you to a random site. So, and XSS is easily solved by, again, escaping the right characters. Making sure that you escape things like angle brackets, and because of course, that's an angle bracket, but the other thing it is LT semicolon. So if you replace that angle brackets with that, then it'll show up as an angle bracket, but it won't, the browser won't see it as an actual script. So cross-site scripting is all about inserting scripts into another page and getting them executed and doing something harmful with them. And XSS is, XSS problems, see rule number 1. Sanitize people's inputs. That's absolutely correct. But also outputs in this case. It's both. Next one is cross-site request forgery. And this one is particularly dangerous, but it can also be solved pretty easy. What cross-site request forgery is it's when one site makes a request on another site using your credentials. And a famous example is like a banking system. So imagine I'm a customer with Bank A, and I'm logged into Bank A's website, and they keep my session open indefinitely. So imagine you as the attacker, you're also a customer of Bank A. And then you go in and you check out how money is transferred. And then you realize that money is transferred by this one single URL that gets executed. banka.com/transfer, account from equals whatever, account to equals whatever. So if you can find that and you can somehow get me to run that URL on my machine while I'm logged into the bank, you could actually cause my bank to transfer you money. And that may sound really crazy, but it's actually the case. If I show you a link and I make the text cute cat pictures, but it's not actually cute cat pictures, I'm actually redirecting you to the bank's URL, then I can cause harmful things to happen. So it is very easy to stop this. The easiest way to stop a large portion of this is to make sure that any GET request that you make as a web developer does not alter any data. It's one of the easiest things. If you do that, you're gonna stop a large percentage of cross-site request forgery, because even if somebody were to take an action or send you to a page as you're logged in, it would not do anything harmful. It's like, imagine if you could somehow convince my browser to go to google.com. That's not harmful. And I may not even realize that you caused my browser to go to google.com, and I don't really care that happened anyways, because nothing harmful there. But if you caused my browser to go to my photos and delete all my photos, of course that would be harmful. So make sure that you don't use a GET request for anything that modifies data. It's that simple. The second way you can prevent it is if you have something that sends a POST request, which of course is totally allowed to modify data, you can use something called a CSRF token, which is nothing more than a unique token that gets inserted into your form and then gets passed back to the server on every request, and then the server can authenticate that token is good to go. And the reason this works is because if I create a false form on another page, I won't know that token ahead of time, and therefore the when the server receives a request from my forged form, it's not going to do anything because it doesn't have that token. And that's a way to stop everything but GET requests. So if you do both of those, then you should mostly be safe from cross-site request forgery. Next is debug mode concerns, and the reason I bring this up is because I see applications that when they fail. Actually, I'm sorry, that's the fifth point. So applications often have a debug mode that you can run in, and CSRF is application provided. It'll be like if you have a Node.js application, there may be a library to just generate a unique CSRF token that you can use in the form, and then it'll check that against wherever it's sourcing those tokens from. The debug mode stuff is that applications generally have a debug mode, and it's designed for debugging, but oftentimes people's applications end up live and in production in debug mode. And that's either because people don't realize that they're in debug mode, or they intended it to be in production mode, but they're actually not. And the reason this is harmful is because debug mode often gives you debugging information. And oftentimes that debugging information contains data that you wouldn't want like an attacker to see. It could be like dumping your entire configuration file right there in front of everybody, to include passwords and secrets and all kinds of stuff. So this is a simple thing to do. Just make sure that debug mode is off. If your particular thing that you're using actually has it, it's a simple thing to do, but it's something that people miss all the time. And it's not just application. Like if you're using PHP, for instance, PHP has a lot of settings that give you debugging information, and a lot of times I go to applications and I still see these things that are outputted. So just be cautious about what mode your application is running in, and be cautious about what error messages you're providing in a production environment. Remember, you can always log everything. You don't have to put it in the browser. The next thing is global error catching. And this is sort of an important thing. Usually when I create an application, I kind of wrap my entire application, it sounds funny, but I wrap my entire application essentially in a giant try-catch block. And I do that to make sure that nothing catastrophic can happen to the application that will lead to anything being outputted into the browser or into a web service that gives anybody any indication on what's going on at a technical level. And I do that just to make sure, because I've seen a lot of times where people catch an error here, they catch an error here, catch an error here, but sometimes all those errors are missed and it bubbles up to the runtime error catching mechanism, which generally just causes a catastrophic failure, and then out comes all this output into the browser. And of course that's very harmful. And that applies whether it's in debug mode or not debug mode. So you got to be cognizant of that, and try to create this kind of last line of defense error catching mechanism to make sure it does not end up in the browser. How about Node? Does it have anything to prevent SQL injection? I mean, Node.js itself doesn't come with a data layer tool, but like even the MySQL module doesn't have it by default. But again, try everything. And it's funny you write that try everything, but a lot of people's applications, they start as an inlet point, and something is executed to kind of kick the whole thing off. And in larger applications that are based on established frameworks that are also quite large, they generally start with a function called like run, or handle route, and then from there it sort of starts branching off to go do whatever it's got to do. But as long as you have that starting point, in a try catch, and you don't have to use a try catch if you can handle the error. If you can ensure that any error that bubbles up past all the try catch blocks, if you can ensure that that ends up in a place that's not the browser, then you're okay. But it's something I like to do, and then I just log those errors to a file, and then I check them out later. How would you protect RESTful APIs from authorized access in particular? So generally REST APIs, usually you authenticate using like OAuth, and then you get a token, and you can use that token to access an API for a given period of time. For a given period, you can use that token to access information for a set period of time and also a set scope of information. So generally tokens will be good for accessing specific data. But the other thing you can do is just an API key that is just attached to a user that allows them to access. As long as you have some authentication, then you're okay. So next thing is databases, and databases has a couple easy things to do. The first one is hashing, and one thing that I see a lot, not so much anymore, but a long time ago, I was constantly taking over projects where I would look in the database, and there we are, plain text passwords, just everybody's emails and passwords just right there in the open, and that's so easy to fix that it shouldn't even be a thing anymore. Hashing, for anybody that doesn't know, is a way of taking some data and creating a unique, like a 32 character or 42 character string of characters that represent that data. Now, hashing is one way. So when you hash a piece of data, you can't unhash it. And especially if it's a larger amount of data, because you can hash like 5 megabytes of data and get a 32 byte hash back. And obviously you cannot reverse 32 bytes into 5 megabytes. It doesn't work that way. But there's a bunch of different hashing algorithms, and some of them are shorter than others, some of them are longer. Like MD5 I think is 32 characters, SHA-1 is 40, and then they go all the way up to 512 or more. And they one concern with hashing is something called a collision, whereby two separate inputs create the same hash, but it's pretty rare, and that's why you can count on hashing being unique. So the way hashing, the role hashing plays in things like passwords is, instead of storing a person's password in the database, you store a hash of that person's password. So like if we're using SHA-1, for instance, so we'll pull up this guy's site. So like if I type Chase, if I make my password Chase, then the hash of that is right here, 702B78 whatever. So what I would do is, if I set a password Chase, I would not actually put the word Chase in the database. I would put this in the database. And by putting this in the database, it means that anybody looking at the database doesn't have access to people's passwords. They just have access to hashes. And then what you do is, the way you authenticate somebody is, when they type their password Chase, you hash the password they supply, and then you compare it against the hash you have in the database. And if it matches, then it's the right password. And this is a way of storing passwords without actually storing the passwords. But it still works all the same. And your users will thank you for it, because if you may think that storing plain text passwords is not a big deal, but it actually is, because you might think, well, so what if they have somebody's password to my site that is just cat pictures? But the problem is people are notorious for using the same passwords for everything. So if I provide you my email and I provide you a password, there's a good chance that that email and password can be used at any number of places, like banks, emails, and so on. So it's important to do that. Sean Carroll asks, what does salting do? So when you have a hash that contains a salt, essentially what you're doing is creating a namespace that just gives you less predictable hashes. When you have a hashing algorithm that is not salted, you can be it could be susceptible to basically pre-computed tables. There's MD5 tables out there where people have pre-computed a number of different things for MD5. So MD5 is unsalted. MD5 is going to create the same thing. But the the easiest way to basically describe a salt, let me open up my SHA-1 generator again. So a salt can be thought of as, with SHA-1, if I type chase, I get 702B78. If I type chase again, I get 702B78. I get the same thing every time. A salt would be like if I made a bunch of random characters and then underscore, and I just attach those to the beginning of everything. So this would be your salt, for instance. And then this, of course, gives us a different hash. So if somebody provides their password chase, you would then attach this salt to the beginning and then compare the resulting hash. And what this prevents is people from creating pre-computed tables, because nobody's going to pre-compute a bunch of hashes with this in the beginning. So that's all salt is. It's just it's almost like adding a unique set of characters in front of the thing that's being hashed, just to prevent people from doing pre-computed tables. That's all it is. Did that make sense, Sean? Hopefully I was able to answer your question. I like using salted algorithms. I think they're better because they make it so you can't pre-compute them, and that's a huge benefit. But there's a lot of hashes, and the thing about salts as well is the salt is not a secret. And the reason it's not a secret is because you're trying to prevent people from pre-computing tables. So there's a lot of passwords that actually store the salt in the hash. And that's perfectly fine, because so what? If I give you my salt, sure, from that point forward you could start pre-computing that, but why would you do that? You're not going to pre-compute a giant table of hashes for my particular salt. You wouldn't do that, because that'd be inefficient. You would instead just brute force a password with my salt, but that would take you a very long time. So I've brute forced salted MD5s with Hashcat and 2NVIDIA. Yeah. Yeah, hashing with GPUs is insanely fast. You can do so many. Okay, next thing is encryption. And encryption in a database, I don't see encryption used that often in databases, I think because people aren't really sure how to do it, but like MySQL has AES encryption built in. You just have to insert things encrypted with the proper key. So 2 points with encryption. If you have to store data that's very sensitive, such as credit card numbers, social security numbers, something like that, you really need to be encrypting these. But the best thing is just not to store them. Find another place to store them. But if you have to encrypt them, keep your encryption keys safe. Don't put your encryption keys in your repo, for instance. Don't do any of that. Encryption keys should be stored safely by people that have access to them, and then they should be only on machines that need to decrypt data. So your database, for instance, if stuff's encrypted in the database. Okay, let's see. More questions. I'm trying to look at the chat as I kind of go here. I think I've got everything so far. Michael asked, does the DB need to be encrypted if the underlying hard drive is encrypted? And the answer would be, it's a tough call. So hard drive encryption is good because if somebody were to physically steal the drive, then the whole hard drive is fine, everything's safe. But if somebody were to just exploit something where they're able to create a dump of the database, then they would still get unencrypted data in the database. So I would actually say that encryption in the DB is just as important as encryption for the drive itself, because they cover sort of two different things. Hard drive encryption is great for physical security, whereas DB encryption is great for like accidental leak of your database. I think that's probably the best answer I can give for that. So you should use them in tandem, because obviously just because the hard drive's encrypted doesn't mean that people on that server can't access data. It just means that if somebody were to steal the drive, then they can't do much with it. Okay, so moving on to code security, and we talked about frameworks and libraries already, but we're going to talk about two other things. The first is secrets, and I see this a lot, and it's such an easy thing to fix. I see a lot of people putting secret information in their repository, whether that's API keys or keys for their storage or even master keys to their entire cloud platform. You know, I've seen that happen before, and when you do that, the problem with doing that is somebody may find it later and use it. The other problem is somebody may find it and say, oh my god, we got secrets in our code base. And then what they'll do is they'll create a commit that removes those secrets, thinking that they actually got rid of them, but really they didn't, because that's not how Git works. You know, once Git has logged something in the history, it's logged in the history forever. So if your application needs secrets, the best practice to do is to store a sample secrets file in your repository that basically just contains kind of placeholders for all these different secrets. Things like API keys and passwords and just whatever. And the sample file will either have like development information, or it'll have just nothing. It'll just be blank. You know, maybe it's just key value pairs where the values are blank. So then what you do is when you need to deploy this application to production, you put it on your production server, and then you make a copy of this sample file, and then you load that file out with all the actual secrets your application needs. And just the ones that your application needs. You know, not all of them. You want to limit the amount of secrets that are in that file. And one important attribute of this file is that it is not tracked by Git. Not tracked. And what that prevents is that prevents it from getting added to the repo, and that prevents it from getting committed to the repo, and that prevents it from being pushed to some unsecure place that's wherever. You know, I mean, of course, places like, you know, GitHub, GitLab, Bitbucket, you know, they should be trusted, but, you know, do you trust them? You know, do you trust them with the keys to the kingdom? You know, do you trust that nobody is snooping around in your repo? You know, I don't. So the easiest way to solve this problem is don't commit any secrets to your code. And then accidental commits. This is kind of a piggyback on my other point, is when you make a commit to your repo, it's there forever. There is a way to remove it, but the way is not to just remove the file and then commit that change, because Git repositories, or really any distributed source control system, the way it works is you're able to access the history of that code for the entirety of time, the entirety that repo has been available. So just because you remove it doesn't mean it's actually removed. There's only two ways to remove it, one more complicated than the other. The first is to basically remove a commit and then force push on top of your current repo. Now this is practical if you just made your very last commit was a secret and then you pushed it up, you can solve that pretty easily. But if it's way in the past, the more complicated method is you can actually remove the prior object that has that file. But there's downsides to that. Like you could never check out that version of the hash again because it would be in an inconsistent state. Rebasing, TechNanner said, rebasing does work, but rebasing changes history and does require you to force push. So, like, rebasing wouldn't be practical on, say, your master branch, where the commit you want to remove is like 200 commits back. Yeah, secrets management is hard. Ansible lets you commit encrypted keys, but it only takes one mistake. That's right. Yeah, secrets management's very tough. You know, people have been talking about that since the beginning of time. You know, the problem with, you know, secrets and keys and things like that is if your application can see them, so can you. You know, so it's not like you can't hide a key on a server, for instance. I mean, if your application needs a key, that key has to be available in plain text on the server. You know, there are these so-called key management systems whereby you access your keys through some API, but the reality of that is, if your application needs a key, then it can see the API key that uses the API to get your key. So there's really no way around it. The best practice for it is just to limit the amount of secrets, store it as securely as possible on the machine, available only to the application. Of course, cut off access to that server to only specific personnel, and then cut off access from the computer from other computers. And that's kind of the best you can do. You can use a key management system, but it has its own challenges. It adds overhead, and yeah, K8 has one, but it's complicated. Yep, it's a tough one. Secrets is messy business. So the last thing I'm going to talk about is just something that's specific to like C, C++, things that are not protected against, things like buffer overflows. And I say not protected, but they have some level of protection. For those that don't know what a buffer overflow is essentially when you allocate 32 bytes of storage and you try to write onto that 33rd byte. And when you do that, you're essentially writing onto memory that you don't own. Now, in most applications, if you write onto memory that you don't own, the operating system is going to see that you've done that, and it's just going to stop you. It's going to say, nope, it's fault. The operating system, just because you try to read or write to memory you don't own, doesn't mean the operating system is going to allow you to read or write to memory you don't own. So it's going to stop you. The real harm comes from if you try to write onto that 33rd byte, but your application actually owns that 33rd byte that's being used on some other memory. In that case, the operating system is going to see, oh, well, this application is writing to memory that it does own, but your application is writing to memory that is outside the bounds of what a particular variable can hold. And the reason this is harmful is if you give me an input box that writes to 32 bytes of memory and I give it 40 bytes, I can actually write 8 bytes to another piece of memory. And then in that way, I can cause undefined behavior in the application, and I can possibly use it to exploit that application to gain some particular access through it. Of course, it's not easy, but if you look at like the offensive scary database that contains known exploits for a lot of programs, you're going to constantly see this thing called buffer overflows, and there's a reason that they're all like it. It's because it's a very easy thing to mess up. So if you're doing, I don't want to call it low level. Of course, C and C++ is not really low level. It's still considered a high level language. But when you're doing coding in these languages that don't prevent these out of bounds kind of array manipulations, then you need to be aware of buffer overflows, underflows, stack smashing, heap corruption, and all these other matters. And I actually have a bunch of videos on my channel from my early days where I cover a lot of this in depth. It's actually a really interesting subject matter. If you haven't checked it out, you should certainly do so. It's my really old videos. Oh, cookie. I forgot. We gotta circle back to something. So one last thing in web development. I totally forgot about cookies. This is another really simple thing. When cookies are a way to maintain sessions between your requests. So when you authenticate with the server, like EMKC, when you authenticate, I store that you're logged in, and I store that with your particular session hash. I then send that session hash to your browser every request, and then your browser sends it back to me every request. And that's how browsers maintain state with each other. The problem is the cookies are essentially the keys to the kingdom. And if they're not protected, then they can just be taken, like with an XSS attack. So, however, there's one really easy thing you can do, and that's you can specify the HTTP only flag. And this is so easy that everybody should do it all the time. So we're gonna open a private window here just so I can get a get a good read on this. So I'm going to go to emkc.org. And you're going to see when I do this, I'm going to come over to my dev tools here. And you can see engineerman.sid. You know, this is of course the session ID value, but you can see this little check mark with HTTP. That's the gold. It's the gold mine right there. And when you look at headers, you can see the set cookie. See, it's doing engineerman.sid. And at the very end here, it says HTTP only. This is so important, and here's why. When I do document.cookie, you can see that it gives me absolutely nothing. If that HTTP only was not present, it would have given me this session ID from document.cookie. And if I can run document.cookie, so can a script that was injected with XSS. And if an XSS script can read document.cookie, it can send that cookie to another server, and that's game over for you. And all you had to do was just add HTTP only to your cookie. That makes it so that basically what it's saying is only send this cookie on HTTP requests. Don't allow JavaScript to access it. So this is huge. And this brings me to another point, is a lot of people fail to realize that the browser is trying to protect you. So things like the same origin policies, things like secure cookies and HTTP only, and preventing some of these attacks, the browser is protecting you. Like if you use an insecure browser or an old browser or an unnamed browser, and that browser does not know how to interpret the HTTP only directive on the cookie, you may be able to do document.cookie and it'll give you the session ID if you're using a bad browser. So just by using a bad browser or an unnamed browser could cause you to leak your cookies just because it is failing to understand what HTTP only means. So that's kind of one point I wanted to make there, is the browser is trying to help. The browser gives you a lot of security features built in. Okay, we're at the end of the stream. Let me just see if there's any last minute questions. I'll do like 3 minutes worth of questions, and then we'll wrap up here. Let's see. Tesla in Space said, what can I do to secure my remote SSH connection? I port forwarded my home server, and I have forwarded to a 5-digit port and only use public key authentication. I would say you are doing everything you can. If you're using a non-standard port and you're doing only public key auth, then I would say that in the terms of security, you are doing the best that you possibly can in that case. Let's see. A couple other questions. Avi12 said, what's salting? I answered that above, or I answered that in the video already. Let's see. Any reason they wouldn't have, John Donnelly said, any reason they wouldn't have HTTP only? No, I can't imagine any reason why that'd be the case. How do you store private keys, both physically and digitally? So private keys are just stored on your computer in a folder for your user. Public keys are, of course, public. They are not a security risk. You can share them with anybody and everybody. There's no security risk for that. Let's see here. I think, okay, that's all the questions that they've sent to me here. So, all right, we're going to wrap up. So, we have a Discord server. If you haven't heard about Discord, we have about 5,000 people on there. Somebody will post the link here in a second. And we do a lot of talk about tech there. I'm always on there. There's a really great staff there that curates the conversation really well. You should come check it out if you've never been there. There's probably 700 to 800 people that are active at any given time. And we've got a lot of different categories for a lot of different chats, whether you're interested in computing or networking or security or robotics, hardware, operating system matters, artificial intelligence, machine learning. There's a lot going on there. It's active pretty much 24/7. It's a very positive community. Nobody's ever gone there and thought that it wasn't a good time or useful to them. So certainly, if you want to come say hi to me on there, you can. I'm always chatting with people on there. There's a lot of regulars on the stream today that I see all the time. Thank you for coming to the stream. And they all know that I'm on Discord 8 hours a day at least. So it's easy to get in contact with me if you want to come say hey or give me a shout out or something like that. And other than that, I got a video coming tomorrow, and I think it'll be good. I'm going to be doing a re-upload of, hey, Michael, Aaron, thanks a lot for that. Thanks for the live stream and answering all those questions. No, thank you for asking them. Thank you for being on the stream. I really appreciate that. And thanks for the $5. It's very nice of you. So come see me on Discord, or come. Also, I think you mentioned that proxy server. Mention that here or on the Discord. And then if you're just tuning in now, of course, we're done, but this video will be uploaded at the conclusion of the stream, so you can watch it later. Other than that, thanks to all the regulars for attending. Thanks again to the staff for helping me out. Thanks, Michael, for the 5. And yeah, if you're on Discord, let one of my staff know you get a special role on Discord for donating. So thanks a lot for that. All right, hope everybody has a fantastic rest of their weekend, and I will see you on the video tomorrow or in Discord. Have a good day.